So if you're trying to take points and write a scatter plot for them or draw a scatter plot, everything that you're going to do is under your stat key. So you'll see your STAT key, your stat key. So right here on your calculator is your stat key. So that's where we're going to input our data, and that's what we're doing. When we input points of data, we're doing statistics. So if you click on stat, your choices are edit, sort, clear list, or set up your editor. We're going to put something in, so we're going to edit. So you can either hit enter or you can just type in the number 1. If for some reason you don't have L1, L2, L3, they should be named in order, then you have a little bit of a problem and we'll have to talk separately. We're going to put our X's in L1 and our Y's in L2. So in this problem, your X's were your years since 1999. And your Y's were your movie ticket price. And so they just go in as ordered pairs. So 0, 1, you hit enter and they go down. 2, 3, 4. And then when I use my right arrow, it goes back up for me. So in year 0, the ticket price was 5.08. In year 1, the ticket price was 5.39. Then we were at 5.66, 5.81. And 6.03. You have to have the same number of pieces of data in the L1 and the L2. If you have extra stuff in L1 or L2, you're going to have to delete it out. So if there are 1, 2, 3, 4, 5 X's, you need to have 1, 2, 3, 4, 5 Y's, and they need to be matched up. Are there any questions? So what you might want to do right now in your notes is write your little calculator commands. So stat, edit. So to input data, stat, edit. If you do not have a calculator at home, you're either going to have to do all of this by hand, or you're going to have to come and check out a calculator. To check one out, you have to borrow it after school and return it the next day before school. So they need to be checked out every night because I have to have 34 at all times. But I will let you check one out. All right, so I would like to graph this. Normally when we graph, we go to y equals, but I'm not graphing an equation. So if you look above y equals, what does it say in that other little color? Stat plot. What a coincidence. I have stats that I would like to plot. So I go second y equals, and it takes me to my stat plot. Now, I have to turn each plot on. So I'm going to select number 1. I can either hit 1 or enter. And right now my plot is off because off is highlighted. So see where I'm flashing on? Okay, so let's clear this. Some people are lost. Let's go back. I'm on a regular screen, anywhere on my calculator. I want to graph my stat plot. So that's on mine it's blue, yours may be yellow. So I go second y equals. That second button will take me to everything written in the other color. And I'm going to pick number 1, either enter or type in a 1. And I'd like to turn the plot on so it can be graphed. So all I have to do is hit enter. So my plot is now on. And then my arrows get me through the calculator. So these are all the graphs I could graph. So this first one here is a scatter plot. The other graphs are things that you'll actually do in statistics. And so I'm going to arrow down. All of my X's were in L1, so we're good. And all of my Y's were in L2. Those are the defaults. That's why I said put your X's in L1, your Y's in L2. If you put them somewhere else, you now have to tell your calculator to go find it in that place. Okay? So if you just always X's L1, Y's in L2, you don't have to tell your calculator anything. Now the problem is if I go to graph this, my calculator right now is set to graph from -10 to 10. So if my data is not from -10 to 10, it won't show up on my graph. So the way I do that is I want my graph to match what I've just put in. I want my calculator to go find this data and match a window to fit it. So if I click around here at the top, if I click zoom, my calculator gives me lots of choices. But I put something in stat, and then I did a stat plot, so I'm going to want to zoom stat. Okay, see how they all go together? So stat edit, put our stuff in. Stat plot is how we graphed, and now we're going to zoom stat. So you can use your arrow on my calculator. Zoom stat is number 9. So I'm going to go to zoom stat. I either can hit 9 or just hit enter. And my calculator scatter plot will fit my screen. So there's my scatter plot, which doesn't help you graph it because you still need to know the exact points, but it at least lets you see that your graph matches mine. Now, my calculator will calculate the line of best fit. And so that is called, if we go back to our notes for a second here, when I said you have a line of fit, you also have the line of best fit. And it is called a linear regression line, or an LSRL. It is the least squares regression line. So the regression tells me how far off I am, and I've picked the line that has the least amount of squared error, the least squares regression line. That's what your calculator automatically finds when you do a linear regression. So you may hear me call these prediction equations, lines of best fit regression equations, or LSRLs. It's all the same thing. On your calculator, you can go to Stat again, and this time I'd like my calculator to calculate. So across the top here, I have this calculate menu. So I toggle right and I pick calculate. And there's a whole bunch of choices I have. And one of them should say LinReg, linear regression. If you have a newer operating system, you may have two things that say that. They're the exact same. It doesn't matter. So I'm going to go down on mine. It's number 4. So I can arrow down here to where it says LinReg AX plus B. So A is my slope and B is my y-intercept. So I'm just going to hit enter. And my calculator is asking me where to go to get my points. If x's are in L1 and y's are in L2, all you have to do is hit enter, and it will come up with the equation. So y equals 0.232x plus 5.13. So this is the best prediction equation. It's got the least amount of error of any equations that I could possibly write that go through those points. So, So according to this, on average, because it's not exact, movie ticket prices go up 23 cents every year, and movie tickets were about $5.13 in the year 1999. All right. To find this, stat, over to calculate, and then we're going to pick linear regression. LinReg. It's the one that looks like y equals mx plus b. And as long as your x's are in L1, your y's are in L2, all you have to do is hit enter. If you have a new operating system, it'll say x is L1, y is L2, and you can just go enter, 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 enter till it says calculate at the bottom. That's what you were supposed to do, right? So to input data, you go to Stat, Edit. To graph, you go to second y equals, which is your stat plot. And to get a least squares regression line, you go to Stat, Calc, and pick linear regression. So your notes definitely should have those so you can use this, right? Go back through it a few times. Once you do this 2 or 3 times, you're not going to have a problem. Just think about what you're doing. Stat, if I'm entering it, I'm editing. Stat, calculate, gives me the equation. Stat, plot, plots the points. L-I-N, Lin. Now, even though some of my data, like this data looked pretty close to being linear when I looked at my graph, I mean, it followed somewhat of a linear equation, my data doesn't have to follow a very good linear line for slope to matter to me. If you go back to the front page of your notes, I gave you a graph that looked like that. That is clearly not a linear equation, right? No question. So even though that's clearly not a linear equation, slope matters to me. Because what I can do is I can say, all right, slope is a rate of change, right? It's how much y changes in terms of x. So if I have any 2 points, even though this isn't linear, I could take those 2 points and I could calculate the slope between them. And so in this case, this was the concentration of a drug in your blood over time. And I could actually look at this and say, all right, to go from that point to that point, there's my slope. Now, I know it's not linear, but slope still tells me the rate of change between those 2 points. So as long as I've got 2 points, even if my data is not at all linear, I can calculate the rate of change between 2 points. That's what slope gives me. And if you think back to geometry, there's a name for this line. If it's a line that goes through 2 points on a graph, what do we call that? What do we call a line that goes through 1 point and only 1 point on a graph? No. A ray goes in one direction. But if I have a graph and there is a line that goes through 1 point and only 1 point on that, a tangent line. So that is the study of calculus. The study of calculus is finding the slope of a tangent line, finding a slope that only has 1 point. That is the heart of what we do in calculus. The heart of what we do beyond or before calculus is we find a slope between 2 points. Any line that goes through 2 points is called a secant line. So if I ever ask you to find the rate of change, what I'm really asking you for is the slope. You just need to know that anytime you're asked for the slope, it simply means find the rate of change. So even if I have a scatter plot, I can find the slope. Even if I have a graph that's not linear, I can find the slope. Slope still has a meaning to me. Now, slope just means the rate of change through those 2 points or through the secant line through those 2 points, but it still can use it. It can still be meaningful. All right, let's try one more so we can play with our calculator a little bit more so you can try what you know how to do. Let's see. So I think the next example is measles. Is that the next exciting one? All right, so mumps. Here's the mumps cases starting in the year 1995. We had a lot of mumps cases, 906. In 2003, they were down to 56 cases of mumps per year. And this is data from the Centers for Disease Control and Prevention, like the CDC. Okay, they analyze all this stuff. So here's my graph. We could enter 1995, 97, 99, or what we could do is just say X could be the number of years after 1995. And then Y would be the number of mumps cases. That makes graphing and finding my equation so much easier. So this would be 0 years after 1995, 2 years, 4 years, 6 years, and 8 years. I could do it either way, but I'm going to get a different equation. Okay, that just makes graphing a lot easier. So my x-axis when I go to graph is years after 1995. And my y-axis is number of mumps cases. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, my y-axis, what's my smallest value that I've got to encompass? 56, but what's my largest? 906. So I've got to count all the way up to 906. So it's not going to be a very detailed graph. I might need to count by 200s, 200, 400, 600, 800, 1,000. So for my scatter plot, 0 years after 1995, I'm at 906. So that would be about halfway between 800 and 1,000. 2 years later, I'm at 683. That's close to 700. Then at 4 years, I'm at 387. That's just shy of 400. At 6 years, I'm down to 116, so just over that halfway mark. And at 8 years, I'm down here near 50. So it looks like as time progresses, right, as further and further after 1995, the number of mumps cases declined. There might be some sort of relationship there. I don't know, maybe at some point in there, everybody started to get vaccinated for mumps. So it's one of our common vaccines now, so we saw that decline. Now, it looks like it's going to follow a linear trend, but I don't know an exact line. So we've drawn a scatter plot. Determine what relationship. Well, we think the number of cases declines as time after 1995 goes up. We think there is a strong negative relationship. Now we're going to draw a line of fit. I want you to find the line of best fit. So we're going to go to our calculator to do this. So on your calculator, you already have data, and you need to get rid of it. So you can just go ahead and reset your calculator. So we have practice doing that. Second plus, I'm going to reset all RAM, And yes, I really want to reset. Where do I go to input data? Stat. Go stat to stat. Go stat, edit. So these are years 0, 2, 4, 6, and 8. And then I had mumps cases, 906 in year 0, 683, 387, 116, and 56. I'd like to make sure my scatter plot looks right. So if I have stat that I'd like to plot, where do I go? Stat plot. See, math people, not creative, right? So that's above y equals. So I go second y equals. I'm going to go to plot 1. I'm going to turn it on. That scatter plot. My x's are in L1. My y's are in L2. And then I'm going to zoom stat. I'm going to make my graph fit my window, or I should say my window fit my graph. So zoom 9 on my calculator. So there's my graph, which looks a lot like what you got. It even looks like that maybe it tapers out towards the end. Maybe a linear wouldn't be the best fit. But we'll worry about that another time. Let's just find a linear equation to predict it. So where do I go now? Stat, and then over to calc, and I want to pick linear regression, and I can hit enter. Y equals negative 113.35x plus 883. So my slope is delta y over delta x, change in y over change in x. Y was mumps cases, x was years. So a slope of negative 113.35 means that I went down approximately 113.35 mumps cases every year after 1995. So we say there was an approximate decrease of 113.35 mumps cases each year after 1995. Why did I say approximate? That's first of all my equation's prediction, right? It's just the best prediction I could give you. It's not exact. You don't roll into the hospital with a mumps case and they're like, you can't have mumps because we already had 113.35 decrease this year and we cannot decrease it any more than 113.35 cases a year, or we will not be linear, right? I mean, the data, the real world data doesn't get forced to fit the model. The model is just some sort of forced prediction of data. So we always have a slope that's approximate or average if it's real data. Questions? Once I've got this, I could ask you to do things. Like I didn't tell you anything about what happened in the year 2002. I told you about 2003. So tell me, how many mumps cases were there in the year 2002? So what would I put in for X? Not 2002. What does X stand for in this problem? So how many years after 1995 is 2002? So I'd put in a 7 right here, and then I'd calculate that out, and you could use that to predict how many mumps cases we would have had in the year 2002. We can use this to predict what happens later on, like the year 2020. However, there are major flaws in doing that. Statistically speaking, that's called extrapolation. That's taking my data and using it to predict things that are not in the realm of my data. This data did not encompass the year 2020. So to extrapolate out to the year 2020 has some major problems. They do it all the time, right? If you look at newspapers, they'll use whatever trend to predict things way out, but statistically speaking, there are a lot of errors with that. So this is what you're going to do today. I'm going to give you real world data. You're going to find lines of best fit. You're going to use it to predict something. All right. So let's look at your